Now we're going to take a look at graphical models. So we're going to look at relationships between the different motion graphs for some different types of motion. So the first one we're going to look at is for constant velocity motion. Okay, so if we have our position versus time graph and this is linear, we're going to have constant velocity motion. So this could look like this. Okay, so maybe I just have a nice positive slope right there. If I've got a positive slope on my position graph, that means my velocity is going to be positive. This slope is not changing at all. The slope itself stays constant at some value, not zero. So my velocity is going to be equal to whatever that slope is. Okay, that should be a flat line. It's kind of angling a little bit there. Sorry about that. And the slope of my velocity graph gives me my acceleration. This slope is zero because my velocity is not changing over time. If my velocity is not changing over time, my acceleration is zero. And so our acceleration graph is going to be a flat line right at zero. Okay, now let's take a look at another kind of constant velocity motion. Maybe we have constant velocity motion in the negative direction. So we see a negative slope right there. That means our velocity is negative and it is constant. Okay, but our acceleration is still zero. Okay, so just a couple of examples. Okay, if you want one more, if things aren't going to get too confusing on here, then we'll draw one extra one on here. Let's say that my position is not changing. Okay, so I got a flat line at position. That means my velocity is zero because my position is not changing. And that means my acceleration is also zero. So I got kind of this nice thick line here for zero. So if you hadn't noticed, when we have constant velocity motion, our acceleration is zero because you guessed it, velocity is constant and acceleration has to do with a change in velocity. So next, let's take a look at a set of graphs if we have constant acceleration where our object is speeding up. So if our object is speeding up, then the position changes, does not change consistently over each time interval. So if it's speeding up, we're going to cover less distance at first and then more distance as time goes on. So we're going to see a parabola that starts off pretty shallow and gets steeper. And so what we see happening here is the slope of this line is getting steeper. That means the velocity is increasing. And so I will have a nice linear line. My velocity, it is increasing. And I also drew my velocity as positive because we're headed in the positive direction right here. Okay, and since my acceleration has this nice positive slope linear line, that means my acceleration is also positive. Okay, so I'm just going to put that this color, I've got a positive velocity and we see my acceleration is positive. Let's look at what happens if we're speeding up in the negative direction. Okay, we could be starting anywhere on this graph. I could be starting at positive x, 0, negative x. It doesn't really matter. I'm just going to start from 0 to make it look kind of nice and symmetrical. Okay, so you'll notice this graph is also showing motion that is speeding up, but we're moving in the negative direction. Okay, so we're heading down that y-axis. So if we're speeding up in the negative direction, I'm going to have a negative velocity, and the value of our velocity is going to get bigger as time goes on. It's going to get farther away from 0. And we got this nice negative sloping line here, and my acceleration is going to be negative. So we can see also if we are speeding up but in the negative direction, we're going to have a negative acceleration. Okay, so now let's take a look at constant acceleration graphs, and we are slowing down. So if we are slowing down, we are starting off pretty flat. I'm sorry, we're starting off steep and then getting more flat. So we're going to start off with a pretty steep graph that gradually slopes and flattens out. So this is showing slowing down in the positive direction. But what we see happening here is that my slope is decreasing. It's getting shallower. So I'm starting at some high velocity, and my velocity is gradually decreasing to 0, but we have a positive velocity, so we're on the positive side of our velocity graph. And then here's the tricky one. This is a negative slope. Okay, so our velocity is decreasing in the positive direction. So that means the acceleration is negative. So we're slowing down. We have a positive velocity. We will have a negative acceleration. And lastly, let's say we're slowing down in the negative direction. We're going to start off with a really steep line that gradually levels off in the negative direction. Okay, so we're going to start with some negative velocity that's pretty big, and that velocity is going to gradually decrease to 0. And this one messes people up. We are slowing down in the negative direction. So that means that our acceleration is actually in the positive direction. Okay, because we're traveling in the negative direction, but our velocity value is decreasing. Okay, so the change is actually positive. So in this case, we have a negative velocity and a positive acceleration. So just like we talked about in class before, remember, if we're slowing down, the sign on velocity and acceleration are opposite. If we are speeding up, the sign on velocity and acceleration are the same. Okay, and then the last little bit down here, on our position versus time graphs, the slope is going to tell us the velocity. Okay, and on a velocity versus time graph, the slope is going to tell us the acceleration. And the area on our velocity versus time graph is going to get us our displacement. And so just a reminder, formula for slope. Slope is just our rise over run. Okay, and then formulas for area kind of depends on what area we're talking about. So if I've got a box, that's pretty easy. It's just going to be base times height. If I've got a triangle, 1/2 base times height. And if I have a trapezoid, this is the weird one. So it's 1/2 base 1 plus base 2 times height. And the tricky part is figuring what's your base and your height. So your bases are the two parallel sides. Usually in our graphs, they'll be the vertical lines. And then the height is the distance between those.